choosing a forging process is not a manufacturing preference. For critical components, it is a risk decision. A part can meet dimensions and mechanical properties, yet still fail qualification or service expectations. Buyers therefore ask why this process was selected. First, they evaluate the component's failure consequence. Fatigue, pressure, temperature, vibration, and life cycle all matter. Then they examine load paths and grain flow. Grain flow should support primary and secondary loads. If it is incidental, buyers see hidden risk. Geometry is evaluated against internal deformation requirements. Near-net shape cannot replace adequate internal working. Thick sections create an even greater challenge. The core must receive sufficient deformation throughout forging. Billet size, sequence, heats, and reductions need justification. Buyers also consider volume and program stability. Prototypes and irregular repeat orders demand process repeatability. Material grade can completely change the preferred route. Titanium, nickel alloys, and high alloy steels need tighter control. Open die forging suits large, heavily worked custom components. Closed die forging supports repeatable complex external geometry. Ring rolling delivers continuous flow for circular components. Specialized forging supports directional, load-sensitive component requirements. But no process succeeds through equipment alone. Heat treatment, machining, inspection, and traceability must align. Cost-only selection is an immediate buyer red flag. Buyers expect documented engineering rationale and validated routes. They also expect consistent results across multiple batches. Veneer selects processes around service risk and material behavior. The right process must perform, qualify, and remain auditable.